Hello there, colleagues. I wanted to give you all some feedback. There was one common issue that seemed to pervade for most of the class, and so I wanted to spend some time talking about whether we can assume equal variances or not. So if you got that comment on your rubric, this is to address that. And instead of doing this for each individual person, there were, I think, the majority of the members of the course have some comment about Levine's test or assumption of equal variance. And so if that part of that camp, then you might want to look here at the beginning. For those of you who aren't, I still have some information at the end that may also be relevant, so you might go ahead and stick with us in this video. Let's see, I made my cursor much bigger, so hopefully that'll help be able to see it on the screen. But look here on the independent samples test. Everybody got the right analysis, so that was great. Everyone figured out how to run it, and you ran it accurately. But if you'll notice here, you actually have two rows. You have a row where you have equal variances assumed up at the top, so there you have an F of 2.77, significance of 0.097 for the F Levine's test, and then you have the t-value and the df, and you have the significance and the mean difference, and then you have these other values. And then you have another row, and this second row is equal variances not assumed. And so in this case, if we can't assume equal variances, there's a t-score, there's a df, there's a significance rating, there's a mean difference, and there's slightly different values. So there are two rows, one on the top, one on the bottom. Now, I understand this varies from version of SPSS, from version to version, but my understanding is in most versions, what they will do is if the equal variances are assumed, they will place the F value in the top row. So here in the case of Levine's test, if you have a significant finding, then there are significant differences, and so they are therefore not equal. So in Levine's test for equality of variance, anything above a 0.05 is actually good. Anything below 0.05 is significant and means significantly different. In other words, they're significantly not equal. So if we're assuming equal variance, then p-value should be above a 0.05. And in this case, they are similar enough in their variances, so it reports the F value in this line. As I mentioned, if you had a significant finding, many outputs of SPSS will put let's say that it was actually 0.047. Then it would say 2.77, significance 0.047, and it would be on the bottom line. And that would mean that you report the t statistic from the bottom row. And so in this case, you can see that makes a slight difference here. In this case, we have 0.051 is our significance value, our p-value for the top row. On the bottom row, it's off by 1/1000th. But let's say it was 0.049. Okay, that would be very interesting, wouldn't it? Because in one row, it's not significant. In the other row, it is. And so when you report this, you will report equal variances were assumed, t equals negative 1.96, and the p equals 0.051. If we pretended that this was 0.049 and you had a significant finding on this row, and you had a significant finding here for the test of equality of variance, then you would say equal variances were not assumed, t equals negative 1.967, p equals 0.49. Now that's pretend, that's not what we see on this thing, but that's how you would choose which row you're going to report on. Make sure that your audience, your reader, knows whether equal variances are assumed or not. And in this case, equal variances are assumed because there is not a significant finding of difference. Okay, when you make a decision on which row to report from, make sure your reader knows, because they're not going to see your output. So tell them where you're deriving your numbers from, either from equal variances assumed or equal variances not assumed. We don't necessarily report the findings from this, the Levine's test for equality of variance. We just tell them which column we're drawing this out of. Okay, now this is the other thing I wanted to show is if you're going to represent this in APA format, then you're going to report it this way. And so here T is in italics, okay? And then you have parentheses and your DF shows up here in this, you can see the formulas right here. DF shows up in the next, in the parentheses. And then equals, now usually we put a space between equals, and space between the parentheses and the equal sign. And then another space between the equal sign and the negative. And so you'll report the T statistic, a comma, space, and then P. Remember the P value should be in italics, and then another space, and the equal sign and the space, and then the P statistic. Okay, so if I have a statistic, a significant finding, this is the formula I would use. But notice here that 0.051 is not significant. Now, when you're telling your professor, hey, I got the same number you got, that's the way you're supposed to do it because I need to know that you got the right answer. But if you were writing in a journal or some other publication, just so you know, when we report significant findings, that's when we'll go with this, the actual methodology here. We'll report the T, the DF, the value of the T statistic, and then the P and the P value, right? We're going to report all that stuff when it is significant. In a journal, if it's not significant, all we would say is differences between the means were not significant. P was greater than 0.05. No need to deal with the T statistic because it's meaningless. No need to deal with the DF, meaningless. And in fact, it's even meaningless to tell us what the p-value was, because if it's 0.051 or if it's 0.99, doesn't matter, still insignificant. Okay, so if you have a significant finding, you report it. If you have a non-significant finding, you merely report that you have a non-significant finding. Now again, if you want me, your professor, to know you got the right answer, keep on doing it that right way. But just so you know, you'll find in journals oftentimes to only report significant findings. And of course, there are some exceptions to that. Like if you're doing a big chart or something like that, well, then you'd show everything like in an ANOVA or something. But here for a difference between the two, now, if it's not significant, I wouldn't report it. One last note about leading zeros. So if you're wondering, when do I put a 0 before the decimal point and when do I not put a 0 before the decimal point? Well, there's an easy rule. And the easy rule in APA is if a number could potentially be higher in value than 1.0, then use a leading 0. So as you might have noticed that Cohen's D, for example, could be higher than 1.0. So it can be high. And since it can be high, then higher than 1.0, that would put a leading 0 there. Okay, but let's take a number that cannot have a value higher than 1.0, like a correlation or a p-value. In that case, italics, in that case, we would not put a leading 0 here. We just put a decimal. So P equals 0.036. I don't say 0.036 because a p-value could never be higher than 1.0. Great. Hey, hit me up if you have any questions, but you all are on the same page and you're doing great work. The ANOVA is kind of like running a very complex T statistic because you're going to compare multiple means. So let me know if you have any questions on that one, but really great work here on the independent t-test. Great job.